Hello winners, I hope you're good and you're enjoying your day. So we are going to learn about the nature of roots. Before we get to it, don't forget to hit that subscribe button, like, comment and share. So one could ask, what are the nature of roots? The nature of roots refers to solution of the equations, specifically refers to the characteristics or the properties that can be given to the solution that we find after solving a certain equation. For instance, let's say we are given the example x squared minus 3x plus 2 is equal to 0. Let's say, for instance, we are provided this equation and we are expected to determine or discuss the roots of a quadratic equation. The first thing that we have to do here, we already know that we have to factor out the factors of 2, which are suitable for this equation, and we know very well that the suitable factors are 2 and 1. So x is going to be equal to 2, or x is going to be 1. So after we've done this, we can already get to see that our solutions here are 2 and 1. So 2 and 1 are integers. So that way you can be able to tell that this equation here is real. And again, it's rational because 2 and 1 are integers. But that's not always the case when coming to finding the roots of a quadratic equation. Another thing or another way that we can use to determine the roots without having to calculate all this, going through the steps and everything, it can be so exhausting at times. So there's another way. So stay with me so that I can show you this other way to determine the roots of a quadratic equation. I hope that we're all familiar with this equation. This is called the quadratic equation, right? So the nature of root of a quadratic equation is determined by the discriminant. So this portion here that is written in a purple color is what we call the discriminant. So the nature of roots of a quadratic equation is determined by the discriminant, which is also denoted by the Greek letter, that is called a delta. So we call it the discriminant, which is the expression under the square root in a quadratic formula. We know that this is a quadratic formula, right? So this expression here under the square root is what we called the discriminant. The discriminant is going to be used to find the roots of a quadratic equation. So let me show you how we're going to go on about that. The roots of quadratic equation can be non-real. They can be non-real. So when the root is non-real, it means that the delta, which we mentioned that it's our discriminant, the delta which represent the roots, right? Which means for an equation to be non-real, the root has to be less than 0. And again, the root can be real. For a root to be real, it has to be greater or equal to 0, right? So that you can see that, okay, the root is real. And going forward, when a root is real, it can also yield out an unequal or equal root. An unequal root is a root. It's a root that is greater than 0. If you find a root that is greater than 0, it means that the root is real and it's also unequal, right? And again, the root can be equal. The root can only be equal if our determinant is equal to 0. The root can be equal if our determinant is equal to 0. Now going forward, from the unequal roots that you have, the unequal roots can also be rational and irrational. For a root to be a rational root, it must be a perfect square. For a root to be an rational root, it must be a perfect square. One would also ask, what is a perfect square? What is a perfect square? A perfect square is a number that can be squared and yield out a whole number. For instance, 4 is a perfect square. 9 is a perfect square. Going forth and forth, 25 is a perfect square. It means that you can square that number and yield out a whole number. You won't come out with numbers that have decimals and everything. You're going to come out with a whole number. Okay, so going forward, an unequal root can also be irrational. Irrational roots are not perfect squares. The numbers that are not perfect, the roots that are not perfect squares are those that when you square them, they don't yield out a whole number. They can be in a form of decimals, come out as the square root that it is, and everything. So this is what we mean by the irrational roots. They are not the perfect squares. So I hope this clears out the confusion that you have with the nature of roots. But before we could close it up or anything, I hope that you understood. And for now, let's get to do one example to see if we really got the hang of this nature of roots. Let's work on the example together. You can screenshot this or pause the video and work it by yourself and come here so that we can do it together. We're given the statement saying that discuss the nature of roots of the equation 3 squared plus 8x minus 2 is equal to 0. So here we can see that we're given a full quadratic equation, and what's there for us is to ensure that we get to a point where we will be able to discuss the nature of roots. And I've mentioned before that you don't necessarily have to go through calculating and everything, solving the x and all that. There's a way that you can use. You remember that I presented this to you, right? So we're going to use this discriminant to determine our roots so that we can be able to discuss the nature of roots of this particular equation. So without wasting time, let's get to it. Root is equal to b squared minus 4ac. Before we could get to this, let's take out the important data from our equation. We know that there's 3 here, it's our a. There's 8 here, it's our b. And this, don't forget to take the sign as well, right? Don't forget to take the sign as well. So this is going to be our c, is the constant value. So now going back to determining our root. Our root is equal to b. In a place of b, we're going to put 8 minus 4, and in the place of a, we're going to put what? Going to put 3. close the bracket, open the bracket, and substitute our -2, which represent our c, right? We have it now together. Now let's see what this has for us. Sorry about that. I was trying to grab my calculator, so let me place my calculator here. We're going to press it like exactly how it is. 8 squared minus 4, 3, close bracket, open bracket, -2. Don't forget that these two brackets here represent multiplications, right? Yes. Then we find that our root is equal to 8. Oh, big number. Interesting. That's something we can work with now going forward. So our root is equal to 8. So now going back to that flow diagram that we had, do you think that this equation here it's non-real or a real root? But from how I see it, 88 is greater than 0. So first thing first, this it's a real root. It's a real root. Okay, it's a real root. We see that, we get that. So let's go further. So do you think that this can be equal or non-equal? Do you think our equation is an equal or non-equal or unequal, I might say? So judging from the fact that this 88, which is the number that we got here, it's greater than 0. It's not equal to 0. It means that it's unequal. Our root is unequal. Oh, interesting. Way too interesting. Now, since it's unequal, it now brings us to our third layer, or our third phase of the root. Now, is this going to be rational, or is this rational or irrational? Oh, for it to be rational, it has to be a perfect square. And also for it to be irrational, it has to not be a perfect square. And let's find out. Let's find out together. Square root of 88 is equal to, oh, this is not a perfect square, obviously. So then we already know that our root is going to be irrational. Irrational root. And just like that, you've discussed the nature of root of the equation 3x squared plus 8x minus 2 is equal to 0. You are done. You are done. I hope you got it correct, since I've said to you that pause the video and do it yourself. I hope that you got it as it is. And if you didn't, just stick around. We're going to be uploading more examples for you to finally get the hang of this. So for now, bye winners. Don't forget to hit that like, subscribe, and share button. Bye bye.